Perhaps one of the hardest topics to understand when it comes to Kubernetes is ingress. How do we get an external connection to the appropriate service that's running on one of our pods, especially when we have multiple pods that are running as a replica set, as part of a deployment? Well, Kubernetes does this for us in a very, very simple way. And perhaps the reason why this is very difficult to comprehend is because it's very difficult to teach. Well, my job today is to show a hands-on demonstration as how Kubernetes Ingress work. And not only that, but I hope that you leave this video with a good, solid understanding of how this whole process from beginning to end actually gets parsed through the system with Kubernetes. My name is Tim Patrick, and this is Alta3. Let's go ahead and break it down. All right, everybody, let's just go ahead and get right on into this. Right now, what we are talking about is how we get an external connection through our load balancer to the appropriate pod and the service that that pod is running on one of its containers, okay? So Ingress will plot an efficient path to each of our pods. And the way that Kubernetes does this is quite logical, and it makes a lot of sense. It's one of those topics where you just don't quite get it until you finally get it. It's not really all that complicated, and I think the best way to break it down is to go over a few terms we need to learn, as well as seeing how it works from the command line. So let's go ahead and get on into that. We're going to be talking about node port services, node IP addresses, cluster IP addresses, and load balancing. We'll get into all of this throughout the course of this video. So let's get started with a bit of a hands-on demonstration. What we're doing right now is we're taking a look at a deployment. This deployment has 3 replicas, each running Nginx. Note the container port here at the very bottom is 80. Okay, we're going to go ahead and quit out of here without saving, and we're going to apply this deployment. And these replicas will now be spun up. We can run a kube control, get pods, and there we go. They are all up and running. So now the concern is making sure we can get external connections to our zombie replicas. We do this by creating a service or exposing that replica set. We run the command kube control expose deploy zombie, and this will create that service for us. If we run kube control get svc, our service, we'll actually see that we have a zombie service that has its own cluster IP address. Very cool. We'll explain cluster IPs here in a minute. Now that we've done that, we can actually describe this service. And we can see here that we have various endpoints as well as an IP address for the service itself. Where do those endpoints come from? Very good question. Let me clear this out real quick. Put that back at the top, and we're going to run kube control get pods taco wide. And you can see that every single one of my pods has its own IP address. And those IP addresses are actually called up above. So we have our endpoints 192.168.139.67. Here is 192.168.139.67. We also have 192.168.2472. Here we go, 192.168.2472. And then finally 192.168.84138. And here you have it. Every single one of my pods has an IP address, and that is being stored in this service IP. So the endpoint that we want to point these external connections to is actually the cluster IP, or the IP address of the service that we created. At which point it will be round-robined load balancing by default. There is ways to edit that to one of these pods, to one of those endpoints, 192.168.139.67. etc. Okay? That's essentially how the process works. So we're going to show it on a diagram here in a minute. But let's explain why it is that we need to use cluster IP addresses as opposed to pod IP addresses. Anybody who's been working in Kubernetes for a while knows that pods die. They die quite frequently and for any number of reasons. When a pod dies, Kubernetes will just spin up another one almost immediately. When this happens, chances are that pod will not be provisioned on the same node that it was before, and it'll also have a different IP address. So let's demonstrate this, shall we? If I run a kube control delete pod, and let's just go ahead and delete this one right up here, 192.168.2472, and that's the one we want to delete. We have now deleted that pod, and we can run kube control get pods. Again, you'll notice that 192.168.247 is gone. It's obliterated. Instead, now it is 192.168.247.3 as opposed to 2. Small difference, but that small difference would essentially keep literally a one number difference. That would essentially keep any sort of endpoints pointing to 247.2 from working. It would fail. But here's the cool part. We clear this out and we just quickly go back and describe zombie. You'll notice that 247.3 is in this service. Now, this service is a part of something called kubeproxy, which is essentially a key value store of IP addresses. It keeps track of your IP tables. When a pod goes away, that IP address is removed. When a pod is added, that IP address then gets added in. So if you want to have a little bit of fun here, we can increase the number of replicas that we have available to us. We could do that by using kube control scale deployment zombie, and we're going to set it to replicas equals 5. Now that deployment has been scaled, and we can run kube control get pods taco wide, and you'll see that we now have 5 replicas running. And we're not going to be able to actually do a pairing and look and see directly here, but we're going to run a kube control describe service zombie. And in the describe, you can see that there are the 3 IP addresses we saw before, plus 2 more ... So that lets us know that as we scale up and scale down our deployments, that those IP addresses will be added to the service, making these pods retrievable. Awesome. So now let's go back to a diagram and kind of show how this works. All right, now that we're through our demo, let's actually break down a little bit of what we were seeing and then some right here from this nifty little ingress diagram that we've prepared for our classes here at Alta3. So we have an external connection here that's running GetWebby. It's trying to land on the specific GetWebby endpoint that we have already assigned fully. Here we have our master nodes. Very important we call them out because they have a very important role to play. But remember the service IP addresses that we were talking about here? That was our cluster IP. And you will notice that there is a cluster IP subnet that has the exact same IP address existing on every single node. So no matter which node collects the request, it will know where to send it. That's very important. So for example, our zombie service IP address, let's just say this is zombie, so we'll put a big Z here. Let's say that zombie service IP address or cluster IP address is 172.16.3.0. This is called kubeproxy. And kubeproxy, we'll put in KP, okay, resides on every single node. And that is what stores the IP tables to get all of the traffic to its designated endpoint. All right? So, the way this works, now that we understand where cluster IP is and sort of the place in the system of where it resides on every node, right? And that it's part of kubeproxy, and that kubeproxy is your IP table. Now that we've all connected those dots, let's go ahead and start from the very beginning. So get Webby gets sent into our load balancer. The load balancer will then be given a node port from our masters over here. That node port will be a number between 30,000 and 32,767. All right. And that node port essentially connects the request to the designated service. It's sort of the way of saying, hey, this is the service that you need to be looking up. All right, fantastic. At that point, let's say we're getting a number of requests at the same time. The load balancer will then round robin assign a request to every single one of these nodes in order. It's all designed to try to equally utilize your cluster resources, but it's going to do it in a round robin order. So for the first request, it'll send it to node 1, second request, node 2, third request, node 3. Awesome. That traffic then gets sent into the node to our cluster IP subnet. kubeproxy then looks up the IP table for the service that is being requested. And even though the end pod might exist over here on node 3, kubeproxy is able to forward that request all the way on over to here. It does not matter what node your pod is on. And in short, from beginning to end, that is essentially how Ingress actually works. But I do want to touch on a few other points and continue the demonstration, or at least the conversation, a little bit further, because I want to take a deeper look into kubeproxy and its IP tables. Okay, so we have our API server, which then gets the request from the load balancer, sends it right on into kubeproxy. kubeproxy will then scan its IP tables, and at that point, look at the number of pods that is available to it, and check this out, it will automatically load balance, you guessed it, using the same rule as the load balancer, round robin. Now this is by default, and it is customizable. So it will send it off to, say this is pod 1, this is pod 2, and this is pod 3. It'll send it out in that order. It'll go pod 1 first. For the second request, it'll go to pod 2. And for the third request, it'll go to pod 3, and then round robin back again. Doesn't matter if that pod is on the node that got the request or not. Same node or other nodes, does not matter. It will forward that traffic. Now, a couple things here, real quick. Your load balancer can be anything. It doesn't have to be Envoy. Envoy is just an example. But let's say, for example, we're taking a look at the Alta3 website. Alta3.com book. Awesome. That traffic comes into our load balancer. It will then pick up a node port from our master. Okay? The master will say, hey, this is the node port for the book service cluster IP. Okay, so we have our subnet here. This is the cluster IP address for the book service that is in our cluster. It will then round robin that request to these 3 endpoints. So request number 1 goes to book replica 1. Request number 2 goes to book replica 2, etc. Get the idea. And all of these other endpoints, you will notice, have their own cluster IP addresses. And when those cluster IP addresses get hit, they will also be round robined accordingly. Every single one of these services have their own node port, and so those node ports will be different as well. Finally, let's talk about how this happens internally, because sometimes we need to route traffic internally, not just route traffic externally. Well, the good news is this is pretty much working the exact same way. We have, in this particular case, book replica. And they're checking out a book, and we need to authenticate the user because they want to look at a book that requires maybe a subscription. And so they need to hit the authorization service in order to authorize that user. That certainly seems to make sense. So they're going to go ahead and do a DNS lookup, and now we'll head on back to the API server, get routed, right, through kubeproxy to the auth service IP subnet, or the cluster IP address, which then gets round robined into the authentication replicas to be processed. So we can actually follow that trail, looking up here at the ingress diagram that we've prepared. And let's say that this is our book service, and it wants to make that authentication request. That request goes up through the node to the API server. This is the API server, by the way. Okay. It'll then get load balanced and probably sent to, it could even be sent back to node 3, but let's just say, for example, it gets sent through here, then into our cluster IP address. kubeproxy then routes it to the authentication pod, and it picks it up and sends that traffic forward. Auth will then process the request and send a response using the exact same path. Finally, I just wanted to touch on this last little slide here, and this is very important, okay? This is the reason why we use services as opposed to using pod IP addresses, okay? If we decided to route external traffic to pod IP addresses specifically, we are going to end up having some bad news. That is that these pods do not exist forever. They are ephemeral. They will die. New pods will be provisioned on different nodes with different IP addresses. Next, how do you load balance? Without using kubeproxy or cluster IP addresses or using Kubernetes as designed, how would you load balance a request through multiple replica sets? Suppose you would think, well, I would have to essentially engineer a solution all on my own. Yeah, that would be about what you'd have to do. But why do that when Kubernetes does that for you? So the solution to this problem is to use a service. Use kubectl expose deploy zombie as an example to create that service, and then have your endpoints hit those cluster IP addresses. This injects a load balancer for you, and as the pods die, they will be re-provisioned and services will be updated with their new IP addresses. Everybody, that is Kubernetes Ingress with a hands-on demonstration. In a nutshell, if you have any questions, by all means, please go on down and leave a comment. Let us know. But you can also join us in our Alta3 community hub. There is a link in the description down below that takes you to our Discord server, where you can talk to Alta3 instructors directly, asking questions within our various chat channels, etc., and maybe get you some help that you need. But if you'd like to know more or learn more about Kubernetes, be sure to come on by Alta3.com and register for a course. We'd love to have you. In any case, my name is Tim Patrick. This is Alta3, and I'll see you guys next time. You have a good one.
This video is brought to you by Alta3 Research. We offer training solutions both on-site and online so that you can choose the method that works best for you. If you like this video, check out the links in the description box below for more information on our course offerings. Please like, subscribe, and hit the notification bell to see more videos like this one. Thanks for watching. We'll see you next time.